Today we will learn laws of exponents. In mathematics and science, it is often necessary to carry out various operations on exponents. To get the correct result of these operations, we need to understand the laws of exponents. In the previous class, we learnt that for non-zero integer a and b and whole numbers m and n, the following rules apply. Just think, will this rule also apply to numbers whose exponents are an integer and the base is a rational number? Think a little. Let's find out. The rule a to the power m into a to the power n is equal to a to the power m plus n will be the first to be discussed. Suppose we take the value of a as a rational number such as 7, the value of m is integer minus 2 and the value of n is integer minus 3. So the left side will become 7 to the power minus 2 into 7 to the power minus 3 and the right side will become 7 to the power minus 2 plus minus 3 whole is equal to 7 to the power minus 5. Let us find out whether the value of both the sides are equal or not. We can write 7 to the power minus 2 as 1 upon 7 to the power 2, that is 1 upon 7 into 7. Similarly, 7 to the power minus 3 can be written as 1 upon 7 into 7 into 7. We can express the multiplication of these two numbers as 1 upon 7 into 7 into 7 into 7 into 7's form. Since 7 is multiplied by itself 5 times in the denominator, we can write 7 to the power 5 in place of the denominator so that we get the number 1 upon 7 to the power 5, which can be written as 7 to the power minus 5. Now as you can see, the values of both sides are equal. That is, this rule is also true for integer exponents. In this way, we can say that a to the power m into a to the power n is equal to a to the power m plus n. This rule will also be applicable for numbers whose base is a rational number and the power is an integer. That is, it is true as a to the power m into a to the power n is equal to a to the power m plus n for a rational number a and integers m and n. Now let's talk about a to the power m divided by a to the power n is equal to a to the power m minus n. Here, if we take a is equal to 7, m is equal to minus 2 and n is equal to minus 3, we get 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 7 to the power minus 2 minus 3. Let's find out whether the left side and right side are also equal here. For this, we will simplify the two sides and compare the results obtained. By simplifying the right side, we will get 7 to the power minus 2 plus 3 is equal to 7 to the power 1. Now we will simplify the left side. 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 1 upon 7 to the power 2 divided by 1 upon 7 to the power 3. Can you tell how will we simplify this division now? Give it a thought. Let's find out. Do you remember that when we divide rational numbers, we keep the first number as it is, then replace the division symbol with the sign of multiplication and take the reciprocal of the second number. Here, the inverse of 1 upon 7 to the power 3 will be 7 to the power 3. This gives us 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 1 upon 7 to the power 2 into 7 to the power 3. Since 7 to the power 2 is equal to 7 into 7 and 7 to the power 3 is equal to 7 into 7 into 7, we will deduct 2 7s from the denominator and 2 7s from the numerator. From this, we will get the result 7 to the power 1, which is equal to the right side. Here also it is verified that for the rational numbers a and b and for integers m and n, a to the power m divided by a to the power n is equal to a to the power m minus n. This rule is true. Now the rule a to the power m whole to the power n is equal to a to the power mn will be discussed. Suppose we take a is equal to 1 upon 2, take m is equal to -1 and n is equal to 2. Under the rule we can write 1 upon 2 whole to the power -1 whole to the power 2 is equal to 1 upon 2 to the power -1 into 2. Let's simplify both sides here too. We can write the left side as follows. 1 upon 2 to the power -1 whole to the power 2 is equal to 1 upon 2 to the power -1 into 1 upon 2 to the power -1. 1 upon 2 to the power -1 means 1 upon 2's reciprocal, that is 2. So we can write it as 1 upon 2 to the power -1 whole to the power 2 is equal to 2 into 2 is equal to 4. Now simplify the right side. Since both the sides are equal, it is verified that for rational number a and integer numbers m and n, a to the power m whole to the power n is equal to a to the power mn. Similarly, you can check the remaining rules. On checking, you will find that all the rules are true even for numbers whose base is rational number and power is integer. By knowing all these rules, we can easily solve the examples related to exponents. So we can say that for rational number a, b and integer m and n, a to the power m into a to the power n is equal to a to the power m plus n. A to the power m divided by a to the power n is equal to a to the power m minus n. A to the power m whole to the power n is equal to a to the power mn. A to the power m into b to the power m is equal to a into b whole to the power m. A upon b to the power m is equal to a to the power m upon b to the power m. A to the power 0 is equal to 1. Today we learned some exponent rules. In the next video, we will see some related examples.
Today we will see examples related to laws of exponents. Example simplify. 5 upon 6 whole to the power -12 into 4 upon 15 whole to the power -12 whole to the power 3. To simplify this, we need the understanding of the laws of exponents. Pause the video and revise them again. Here we see that two exponents are being multiplied in brackets whose bases are different, but the powers are the same. To simplify it, tell us which rule should we use? Give it a thought. Exactly, we will use this rule. A to the power m into b to the power m is equal to a into b whole to the power m. In this way, we can write 5 upon 6 whole to the power -12 into 4 upon 15 whole to the power -12 is equal to 5 upon 6 into 4 upon 15 whole to the power -12. Now if we simplify the multiplication given in the brackets, we will divide 15 by 5 so that instead of 15, we get the number 3. Similarly, we give 4 and 6 as their m, that is, 8cf divided by 2, we get 3 instead of 4 and 3 instead of 6. Then we will find the result of multiplication. For this, we will multiply the numerator, which will come 2, and similarly we will multiply the denominator, which will come 9. In this way, multiplication will result in 2 upon 9. In this way, the given question will become 2 upon 9 whole to the power -12 whole to the power 3. Can you tell to solve this what all rules need to be used by us? Give it a thought. Okay, I will tell you. Here, the rule a to the power m whole to the power n is equal to a to the power mn will be used. By using this, 2 upon 9 whole to the power -12 whole to the power 3 can be written as 2 upon 9 whole to the power 3 into -12 whole. 3 into minus 12 is equal to minus 36, then solution of the given question is 2 upon 9 whole to the power minus 36. By using the rules correctly like this, you can solve difficult questions in minutes. Next example, find the value of x so that minus 27 to the power minus 7 divided by 9 to the power x minus 6 is equal to minus 3 to the power 3. You must be aware of the fact that in an equation both the sides are of equal value. Here, if we somehow equate the bases of both the sides, then we can compare the powers. Along with this, we can also find the value of x. Come, let us solve it this way. All of you know by now that minus 27 can be written as minus 3 into minus 3 into minus 3, which in exponential form is written as minus 3 to the power 3. In this way, to get an equal base for the first value, we can write 9 as minus 3 into minus 3, that is minus 3 to the power 2, minus 3 to the power 3 whole to the power minus 7 divided by minus 3 to the power 2 whole to the power x minus 6 is equal to minus 3 to the power 3. Here the rule a to the power m whole to the power n is equal to a to the power mn will be used. Then we will get minus 3 to the power 3 into minus 7 whole divided by minus 3 to the power 2 into x minus 6 whole is equal to minus 3 to the power 3 minus 3 to the power minus 21 divided by minus 3 to the power 2x minus 12 is equal to minus 3 to the power 3. Now here we can see that the bases are equal. On the left side, the rule a to the power m divided by a to the power n is equal to a to the power m minus n can be used by us. This will give us minus 3 to the power minus 21 minus 2x minus 12 whole is equal to minus 3 to the power 3 is equal to minus 3 to the power minus 21 minus 2x plus 12 is equal to minus 3 to the power 3 minus 3 to the power minus 9 minus 2x is equal to minus 3 to the power 3. Because the value of both the sides is equal and the bases of the sides are equal too, thus the powers would be equal too. So we can say that minus 9 minus 2x is equal to 3. That is, minus 2x is equal to 3 plus 9 is equal to 12. That is, x is equal to 12 divided by minus 2 is equal to minus 6. So here, the value of x is minus 6. Today we saw examples related to laws of exponents. In the next video, we will see some common mistakes made in this concept.
Today we will see some of the common mistakes related to the rules of exponents. Mistake 1. Simplify 6 to the power 5 upon 6 to the power minus 2. Some children do not use the rules of exponents properly. They know that a to the power m upon a to the power n is equal to a to the power m minus n, but do not use it correctly. Not focusing on the signs, they, instead of subtracting minus 2 from 5, they subtract 2 out of 5 and get the answer 6 cube, which is an incorrect answer. Keep in mind that 5 minus 2 whole is equal to 5 plus 2 is equal to 7. So the simplified form of the given question will be 6 to the power 7. Mistake 2. Simplify 9 to the power 6 whole to the power minus 2. Some children, while finding the answers to this question, due to not knowing the rules, end up subtracting 6 and minus 2. This gives them the wrong power of 9, which is 4. On solving this, they answer 9 to the power 4, which is a wrong answer. The power of the power is given here. We multiply both powers whenever the power of the power is given. That is, a to the power m whole to the power n is equal to a to the power mn. Hence, the correct answer to this question is a to the power 6 into minus 2 whole is equal to 9 to the power minus 12. Mistake 3. Minus 2 to the power minus 2 whole to the power minus 2 whole to the power 0 into minus 2 to the power minus 2 whole to the power minus 2 whole to the power 0 is equal to 1. Identify this statement as true or false. Some children do not know that when the power of a number is 0, its value is 1. They think that when the power is 0, then the value of the number is also 0. Because of this false belief, they understand that the given statement is false, but this is a correct statement. Suppose we have to find the result of a to the power m divided by a to the power m. Can you tell what will be the result? Give it a thought. Absolutely right. Since the values of both the numerator and the denominator are equal, the result will be 1. That is, a to the power m divided by a to the power m is equal to 1. Now let's solve the left side. Here we can write a to the power m divided by a to the power m is equal to a to the power m minus m. That is, we can write a to the power 0. In this way, we will get a to the power 0 is equal to 1. So keep in mind that whenever the power of a number is 0, its value is 1. Now look at the example given. Here power 0 is written on top of both the brackets. This means that whatever the number is inside the brackets, since the power is 0, so the result will be 1. And we know 1 into 1 is equal to 1. Since the left side is equal to the right side, the given statement is true. Some children solve the whole statement to get the result. Although they get the right answer, it takes them a long time to find it. While solving any question, it is necessary to see how we solve the question so that we get the answer quickly. Today we saw some of the common mistakes related to the rules of exponents.